All right, welcome to The Explainer. Today we're diving into a shape you've known since high school, but it's got some incredible secrets hiding in plain sight.
Yeah, I know. Seems like a weird question, right? But believe it or not, they both rely on the elegant and surprisingly powerful properties of one single perfect curve.
Okay, so first up, let's start with what's familiar. We're going to unpack this U-shaped curve that, we all think we know.
Right. We've all been there. Math class, plotting points for an equation like y equals ax squared plus bx plus c. You know the one. That classic symmetrical U shape we spent so much time drawing on graph paper.
But here's the thing. This isn't just some abstract thing on a graph. It is everywhere. It's a fundamental shape, like woven into the fabric of the physical world. Think about it. The arc of a thrown ball, the spray from a fountain, even the cables on a suspension bridge. It's basically nature's favorite curve for anything moving under the pull of gravity.
So, what's the big deal? Well, the definition we got in school, it's useful for sure, but it barely scratches the surface. To really get what makes this shape so powerful, we have to go deeper, to its real geometric secret.
All right, let's do it. Let's get into that secret. We're talking about a much more elegant definition, one that the ancient Greeks came up with. And the cool part? It has absolutely nothing to do with x and y coordinates. Okay, so the whole secret boils down to this one simple rule. You just need two things: a single point, we call that the focus, and a single line called the directrix. Now, a parabola is just, it's the collection of all the points that are the exact same distance away from that focus point and that directrix line. That's it. That one simple idea generates that whole perfect curve. And what's really, really cool is that this isn't just an idea. You can actually draw one this way. Just look at these steps. If you grab a pin for the focus and a ruler for the directrix, you can use a little set square and a piece of string to trace out a perfect parabola. See how it works? As you slide the square, the pin is held taut by the string, which guarantees that every single point you draw is following that one golden rule. It's always, always the same distance from the point and the line. So this whole focus and directrix thing, it's not just some neat party trick for geometry class. No, this is the source of the parabola's secret power. This is the property that engineers and physicists have been using for centuries to do some truly amazing things. And this, right here, this is the big aha moment. Because of that special relationship between the focus and the directrix, the parabola has this, it's an almost magical ability to control energy. Check this out. If you make a parabola out of something reflective, like a mirror, it does something absolutely incredible. Any wave, I'm talking light, sound, radio waves, whatever, if it comes in traveling parallel to the parabola's center line, it gets bounced perfectly to that single focus point. It concentrates everything. And it works in reverse, too. If you put a light source at the focus, all of its light rays hit the parabola and bounce off in a perfectly straight, parallel beam. And this one single property, this reflective trick, it is the key. It's the fundamental principle that unlocks a massive range of modern technology. So, okay, let's bring this back from theory to the real world. Where do we actually see this secret power in action? I mean, the list is kind of mind-blowing when you think about it. A satellite dish? That's a parabola, catching faint signals from space and focusing them right onto a receiver. Your car's headlights? They do the exact opposite. They put the bulb at the focus to shoot out a strong, straight beam of light. We're talking solar cookers, powerful microphones, reflecting telescopes. All of them are using this ancient piece of geometry to work their magic. And this wasn't an overnight discovery. It's been a really long journey. If you look at this timeline, you see it starts way back with the ancient Greeks. Guys like Mnemosyne and Apollonius were just studying it as a cool, pure math shape. But then fast forward to the 17th century, and Galileo, he makes this massive leap. He's the one who figures out that the path of a projectile, like a cannonball, is actually a parabola. And then right after that, Isaac Newton takes that reflective property we talked about and builds the very first reflecting telescope. I mean, just stop and think about that for a second. The simple act of throwing a ball, something we all do, is a perfect demonstration of this deep connection between an abstract shape and the actual laws of physics. It's just this beautiful marriage of pure math and the real world. So, let's wrap this up with a final thought. This shape, the parabola, was figured out more than 2,000 years ago. That's long before anyone could have even imagined satellite TV or giant telescopes staring into deep space. It's just a powerful reminder that the universe is built on these incredibly elegant and simple patterns, and they're just waiting for us to discover them and figure out what to do with them. Kind of makes you wonder, right? What other ancient ideas are hiding in plain sight, just waiting to shape our future?